This is Just Tool Basics, and today we're talking about tri-squares. Hello everyone, welcome to Just Tool Basics. Today's topic is tri-squares, also called jointers tri-squares or just squares, even though they're obviously not a square. But the purpose of these things is to test the squareness of something by trying it. And I'm not kidding, that's why they're called that, is you try it to see how square it is. They can measure both inside and outside squareness, and I can show you how that works really quickly. So to measure inside squareness, you just place, this is called the sole plate, against what you're measuring and slide the blade, sometimes called the beam or the tongue, up against what you're measuring, and you just see, try it, how square it is. Now, you may notice that it has a little relief here, so that if there's any sort of sawdust or glue or something like that in the joint, this won't be affected by that, and that's on purpose. That's why it's there. And you can also check the outside squareness of something. Now, I cut this board intentionally askew. Let's put this back aside. So you can see that, it's rarely going to be this severe, but you can tell when something is too acute, and you can also tell when something is too obtuse. And, but that's how it should work. And there should be no rocking, there should be no light that you can see through any of the edges. If you want to be particularly accurate, you can use feeler gauges, which are thin sheets of metal to feel underneath it. Now, that's almost never the level of accuracy that's required in woodworking. Just being able to observe a gap is plenty of information to determine if it's square enough for woodworking. If you get it down to 0.010 of an inch, a very slight change in the humidity of the room will ruin all of your accuracy anyway. So wood is, for better or worse, far less stable than metal. But let's just talk about the basic anatomy of the tri-square. So I mentioned the tongue, blade, beam, whatever you want to call it. I generally call it a blade. This end is called the stock, sometimes called the head, every once in a while called the handle, though there's no real handle to this tool. So the head and the tongue are at 90 degrees to each other, both on the inside face and around the outside face. The wear plates, which in this one are made of brass, help to just extend the longevity of the tool. So as you're scrubbing it against things and, perhaps it gets nicked up or something, then you can polish this out or sand it out to get rid of any sort of damage that may affect its accuracy. There are plenty that only have the inside face with a wear plate, and that's because it's harder to repair the inside. The outside you can just sand, and you can pretty accurately fix that. I prefer it with both, of course. These rivets help, again, with the longevity of the tool. They help prevent it getting out of calibration if you were to bonk it against something or drop it, though you should not drop your measuring tools. But this just helps ensure that that relationship is maintained. Some you may find have graduations printed or engraved along the blade on one or both sides. It's not a feature that I feel like I'm missing out on, but if it had it, sure. This blade is made of spring steel, and that's just to increase the longevity of the tool. Again, spring steel is harder. It springs back to shape. The downside is that spring steel is not rust proof. You can see there's like random little pits here and there, and that's just because I've had this tool for 20 years or more, and over time a little bit of moisture gets on the surface. Now, while this size is pretty good for general woodworking, they do come in smaller sizes. However, personally, for smaller sizes, I use an engineering square, which is generally a metalworking tool. Similar in structure, though you'll note that just one of those differences between metal and wood Metal tends to have a problem of having a burr on one end. So for engineering squares, they are relieved on the inside corner, and the outside corner does not have a relief. I don't know the exact reasons for why that might be, but this is generally how they are. So for smaller tasks, I'll use one of these, and for even smaller tasks, I generally use a double square. This is really my go-to tool, honestly, for small tasks. You can set it up to have a relief in the back, same as the tri-square. This one also is very useful as a measuring device because you can set it to the measurement that you want, and then we'll lock the head down, and then use that to mark with a pencil or marker or marking knife or whatever your preferred method of marking your wood is. And these are accurate enough that you can use them to help set up your machines as well. Make sure your jointer's fence is perpendicular to the bed, for example. So in my opinion, none of these can replace the other two. If I had to skip amongst these three, I'd skip this one because this can cover for this. However, I had this one first, so it's not going to get rid of it because it's slightly redundant. And of course, one last thing that this can do is mark perpendicular lines to one edge. So let's say you had, used a tape measure to measure up a tick mark from, say, this side. You measured up to here. You can use then the squareness of the tri-square to extend that line all the way to the edge and be confident that it's at a right angle. And finally, the way these are sized is by measuring from this inside wear plate face to the end. So as you can see, based on my little mat here, each bold line is an inch. This is a 6 inch tri-square. Until next time, this is Just Tool Basics.